Hello, this is tutorial number 7 on advanced multi-threading in Java and from Cave of Programming, and in this tutorial we're going to look at blocking queues in Java and we're going to look at the producer consumer pattern. So I'm just going to launch into this directly, and we're going to be using a class that implements the blocking queue interface, and the specific class I'm going to use is array blocking queue. So I'll do Ctrl+Shift+O to add the inputs here, and I'm going to give this a maximum size of 10. Now this array blocking queue is a data structure which can hold data items, the type of which you can choose, as with ArrayList, and this queue works in the way that you can add items to it and you can remove items from it, and the items that you remove will be the first ones that you added, so it's first in, first out. And you could add any kinds of items to this, but I'm just going to make this take an integer. I'm going to make it store integers for the sake of this tutorial. Now the really good thing about these classes in the concurrent package are that they are thread safe, so I can access this from multiple threads and I don't have to worry about thread synchronization. And I'm going to have here a method. Let's say I'll make it private void. I'm going to call it producer, and what producer does is it loops indefinitely, and I'm going to make it use the random number generator in Java, because the idea of a producer consumer is that you have one thread that's producing things, and well, one or more threads that are producing things, and those threads add things to a common data share, which is our queue, and then other threads remove things from this queue and process it. So in this case I'm gonna just add random integers to this queue just to simulate doing something in the kind of real world. So I'll say queue, I'm going to use a method called put, and I'll say random.nextInt, and I'll say that I want random integers up to 100. So nextInt brackets 100 will give me a random integer from the range up from 0 to 99, not including 100 here. And this throws an interrupted exception, so I'll just throw this straight out the method if I can. Add throws declaration. So here's my producer, and this could be, for example, a thread that somehow checks for text messages that people are sending if we had a text message server, and puts them into this queue. And now we want some other thread that takes messages off that queue and sends them to their destination, just for example. So let's have a private void consumer here, and what I'm going to do is this consumer is also going to loop indefinitely, just for the sake of simplicity, because of course you wouldn't normally have an indefinite loop, but here I will. And I want this to only take off I want to only take integers off every once in a while. So let's, for a start, make it sleep, thread.sleep for 100 milliseconds every time in this loop. So we'll have like 10 loops a second. And I'll throw the interrupted exception again. And I'm also going to use random here, actually. And what I'm going to do with random here is that I'm going to randomly take things off this queue, because in the real world this would be something that takes things off the queue and takes time to process each item. So it will be taking items only as fast as it's able to, and I'm going to simulate that happening here by randomly choosing whether to take an item or not each time the loop goes round. So let's say, for example, if random.nextInt, and I'll make it count up to 10, and I'll say that if that equals 0, then I'll do integer value equals q equals q dot take, and I will output the value that I've got here, and I'll say taken value, and I'll say value, and I'll also say queue size is, and I'll output, and blocking queue has a kind of size member just like ArrayList does, so QUEUE dot size. Okay, so now the really great things about put and take, well, there are two really great things about them, because for one thing there's no synchronized keyword anywhere here, and there's no need, because that's all taken care of for you here with these Java util concurrent packages, of which this is one. And the other great thing is you can say, okay, what if there's nothing in the queue? And in that case, take will patiently wait here until something is added to the queue, and then it will take it and return it, which saves you a lot of effort, and it doesn't consume too many resources while it's waiting or anything like that. And then put will, supposing the queue's full, and in this case it would be full after only 10 items, put will patiently wait until items are removed from the queue, the size is less than 10 and there's space in the queue, and then it will execute. So both of these methods are incredibly friendly, and they work within your system resources, which is really fantastic. So to see this in operation, let's have a couple of threads. I'm going to say thread t1 equals new thread, and I'll say in here new runnable, and I'll have my public void run method here, and I'll say producer, and I'm going to have thread, actually what I'm going to do is I'm going to handle the interrupted exception here as well, if it will let me. So oh yeah, I also need to say, of course, these have to be static, because I'm just working with static methods here, and I'm also going to make my blocking queue static, private static, everything static basically, for the sake of simplicity. And then I can handle this try catch, and I'm going to have another thread here running my consumer at the same time. So T2, and this is going to be consumer. So and then of course I need to actually start the threads, so T1.start, T2.start, and I need to wait until they finish, which will be never, so I'll kill my application with the red kind of kill button down there in due course. And I'm going to throw the interrupted exception out of main, just so that I can not have to handle it for the moment. Okay, so if I run that, what happens is, so the producer is gonna add things as fast as it can to the queue, of course. So my producer is just adding things as fast as it can. But you notice that because the consumer is only taking things off, it's actually, well, this loop happens 10 times a second, but it's only 1 in every 10 times on average that it takes an item, so it's only on average once per second. But the interval is irregular, because I'm doing this random thing here, which is only true 1 in every 10 times. So when the queue is full, which it is much of the time, you can see here queue size is 10, but sometimes it's 9 if I've just taken an item off, then put patiently waits until the consumer has taken an item off the queue, and then it executes. And of course, like if the queue is empty, then take would wait until there was an item on the queue. And so you have this very nice behavior here where everything is just beautifully synchronized, and you're not even having to worry about thread synchronization at all. So if you've been following the series of tutorials, this is kind of maybe the missing piece that you'll need to really successfully implement your kind of multi-threaded applications, because it's always best to avoid low-level synchronization with the synchronized keyword yourself if you can. And it's always best to try to use these things if you can in the Java Util concurrent package. But having said that, in the next tutorial, just in case you need it, we're going to look at how you would do this using low-level threading techniques with notify and wait and the synchronized keyword. So join me again next time and have fun with this. You can find this code on caveofprogramming.com, all one word. And until next time, happy coding.